Hi, I'm Chad Lawson. This is my magic wand, and you're watching Verbose Mode. Welcome to Verbose Mode, the show dedicated to learning to learn and the freedom to fail. I'm your host, Chad Lawson. In today's episode, we're going to take a quick break from the Internet Radio Project and talk about an aspect of the show that a few of you have asked. I've been very grateful that a few people have reached out asking about how it is I'm controlling the show and what is this remote I've had in my hand. So we're going to talk a little bit about the remote itself and the decisions that went into that as far as for controlling the show. Now, in season 1, I had this box sitting on the desk. You could only see me from about mid-chest down. So I was able to keep this out of view. And if I go over to the overhead, you can see it's a little black box. It's a 3D printed enclosure. Just inside is this, what's called a trellis that I got from Adafruit. It's a 4x4 array of squishy buttons with LEDs, and then inside in the next layer, this was originally designed around an Uno, but I am instead using what's called a Teensy. It's an Arduino compatible microcontroller to do this. And so I was able to keep this entire thing just out of frame below what you could see on the camera, and I could control which camera angle I was going with, as well as being able to put up various overheads and so forth. At the time, I was using a program called Wirecast, and it allowed for multiple layers and multiple control levels. It was an incredibly powerful system, but it was also a lot more complicated than what I needed or, quite frankly, wanted. So with this season, I decided, as I'm bringing things up a notch, as you can see, I've got this brand new set built by Ron Scott Fry. Thank you, Ron. And I'm embracing this retro future theme that I have going on, so I didn't want to use a simple box. And since you're obviously going to be able to see me, whatever control I was going to be able to use was going to be visible in the show as well. My original plan was to build something small and compact, so small that I could palm it in my hand and you barely be able to see it. All right, well, that particular design concept went out the window once I found this. I was thinking about retro remotes, thinking about remote controls of the past. Now, in my day, I'm not going to tell you how old I am, but in my day, I was the remote control in our house. I sat closest to the TV, probably a little bit too close, and so whenever Dad or Mom wanted the channel changed, I would lean forward and change the channel. So early TV remotes were connected to the TV with a cord, and in my early teens, preteens, I did some babysitting for the family across the street, and they had a wired remote, and it was still the first time I saw the remote. What was funny is their setup was such that you were only about 8 feet away from the TV anyway, so even the corded remote you could reach if you really wanted to. It didn't take that much to get off the couch. Now it takes a little bit more for me to get off the couch. So I wanted to, and then the next generation of remote controls that I saw, the first wireless remote controls, the reason they were called clickers, and you may have heard the term clicker to refer to a remote, inside some of those early remotes were a bar. Think of like wind chimes that you'll see, the little metal rods, and there was, when you push the button, it caused a small little hammer type mechanism to strike the bar and create a sound. And the TV had an ultrasonic receiver that would hear that. So what you tended to hear was more of the click of the hammer hitting the bar, but the sound that it was producing, like a xylophone, was higher than the ear could actually hear, but the TV could. And that's what determined to go to the next channel, the next channel, the next channel. A lot of the remotes I've seen from that era had one button for on and off, and one for channel up, one for channel down. Sometimes I've seen more elaborate ones where they also had the volume, but for the most part it seemed like volume was secondary to changing the channels. Now, the next generation of remotes that I saw still used sound, and that's what I have here. I went onto eBay and I was searching just for retro remotes, and I saw this remote and I thought, this is gorgeous. I'm going to go to the overhead real quick. These Magnavox remotes. Now, what was funny is the eBay auction listed them as, it showed the two side by side. Nowhere in the description did it say 2 remotes. It said Magnavox remote, but the pictures kept showing 2, and I didn't take anything for granted. I was pleasantly surprised when it showed up, and there were in fact 2 remotes in the box. Now, what's kind of funny is, in my youth, I didn't care for a lot of the look of tomorrow, if you will, of what they had. Like, if you watched the original series of Star Trek, the original tricorders had a lot of that black and chrome, what looked, I don't know if it actually was kind of leatherette, but had a patent leather type look to it. Not patent leather, had a leather look to it. This leather grain is the word I was looking for. I thought they were ugly as snot. In my youth, I thought a lot of that retro technology was ugly. Well, retro technology. Then it was just called technology. And my father worked for Illinois Bell, so going to his work and seeing some of that tech, I thought it was ugly. I looked at sci-fi and I thought of things more like what we would see in some of the more shinier sci-fi of the future. But as I've gotten older, I've really come to appreciate that tech. Where in the past I liked Star Trek The Next Generation's tricorders, now I prefer the original series. And as you can see with the new set, I've really come to appreciate and love that vision that we had in the 50s and the 60s of what the year 2000 was going to be like. So I couldn't help, but as soon as I saw these remotes, I had to have them. I absolutely had to have them. So I immediately, and let's go back over to the overhead, took the one apart. Luckily I had 2. So I've gone ahead and taken the screws out here just so I can show you. Inside, in this particular one, actually was the original battery. Now, what's interesting, this is what says Duracell Malloy, and it says, let's not do that again. It says that it's 8.4 volts. It also happens to say Mercury battery. I'm not sure how smart it is that I'm holding a battery that contains a lot of mercury in it, and it's 8.4 volts, and who knows how corroded and ugly this is. It probably wasn't a good idea that I dropped it just then either, but that was the original battery in here. Now, rather than continue taking this apart, I want to leave this intact, and I'll talk more about that later, but I did take from the original remote, the one that I'm actually using. This is the original board, and this kind of goes to what I was talking about. In the original design, this one sat down, as you saw, in there, and underneath are the 8 buttons, each of which has a little plunger on it, and those plungers go through these 8 holes. When one of the buttons is pushed, it makes contact with the connections up here, and it routes power then. You can see I've got my black and red wires here for the batteries. It routes power through one of these capacitors on the side, and then through the coil, which produces the ultrasonic sound. This particular connector here has no capacitor on it, so it's actually 0, 1, 2, 3. It's different variations of the capacitor to modulate the frequency and change the pattern as it goes out through the emitter. I think this is really cool technology, and I kind of felt bad for slaughtering this one, but not too bad, because you'll see that because I have the other one, I have plans for this for a future generation. But for this particular version, in fact, the remote I'm using now, I had to sit there and make a decision between how am I going to do this? Am I going to do this through radio? Am I going to do this through infrared, like the next generation of remote controls that used infrared light? And it's the ones you'll find all over in your house these days. I have, for some of the overhead lights, I have this little infrared remote, and it's just pulses of light that command the device on the other side to make a decision. So I could use infrared, I could use radio. In the end, I decided on Bluetooth. And some of the considerations I had for what was going to be the technology that went into this remote were I wanted to use a microcontroller, much like with the black box, that would provide the ability to do keyboard emulation. I wanted to be able to just push a button and have the receiving computer just consider it like I'd hooked up a keyboard. I wanted to be able to have a rechargeable battery inside it, and I wanted to be able to turn it off without taking the entire thing apart. I wanted the unit to be able to run for a long period of time. I wanted all 8 buttons to be usable. So I was looking at various microcontrollers, different Arduino clones. I was looking at the different communication channels from Bluetooth to infrared. I ended up settling on Bluetooth. Okay, so if I'm going to use Bluetooth, I can get a microcontroller. There are plenty of Bluetooth breakouts. But I still wanted rechargeable power. So now I'm having to get some sort of breakout board to do rechargeable battery control. And I wanted some sort of switch to power the whole thing off. So now I'm actually taking up a lot of space in here with different breakout boards when I found that there was one component I could get to do all the work for me. I'm going to go to the front camera, I think, for a second. So this particular microcontroller that I'm using in here, in fact, actually, let's go to the overhead. This microcontroller is what's called a Feather by Adafruit. They actually have an entire ecosystem of feathers, each of which has a different particular specialization. They're all Arduino compatible. They all have a LiPo battery connector. They all have rechargeable, that you can plug it in through micro USB to not only charge the device and program it. So it's everything I could need in one place because one of them has Bluetooth. There's other ones for doing Wi-Fi communication. There are some that do data logging. I think there's one for GPS, or maybe that's one of the shields. So I managed to, with one component, get everything I wanted. I have my battery, I have my Bluetooth, I have my microcontroller that has my 8 inputs. In this particular case, I'm going to go back over to the overhead. If you're looking at this and thinking this is some god-awful, horrible, ugly soldering, you're not alone. So do I. But it gets the job done. In fact, this board right here is the second generation, the second version. The first generation is still in the remote. So what I learned while going through this whole process is I put together this board. In the first version, I had the header for the microcontroller coming all the way up through so that it was closer to being flush with the edge of the buttons. I was using tactile, I think they're 10 millimeter, 12 millimeter buttons. So they're much larger buttons and they make a much bigger click. In fact, you can probably hear when I push the buttons, they make a much louder click. It's like a clicker. And that was not my intention to make a clicker, but nonetheless, I've got it. So I had that coming through. I had all the wires going between the microcontroller headers and the buttons done on this side, as well as for the switch. That ended up being a really, really bad idea because it left me with a very small amount of space to go to work on these buttons. And some of the soldering job, I tried really hard. I was using a fairly fine gauge wire, and some of the wires, some of the solder, trying to do it on permaboard, I ended up, while trying to make the jump between two pads to hold the wire to the pin, ended up joining with an adjacent pin. It required a lot of practicing with me with desoldering as well. And one of the challenges came into the fact that while working on this, I did an initial test, and I just have it set so that it would send the keyboard, the keys 0, 1, 2, 3, 4, 5, 6, 7 through the keyboard. So my initial test, I hooked it up to a computer, pushed the button, and I got 0, 1, 2, 3, 3, 4, nothing, nothing. Oh no, I think the last one was also another 3. So clearly I had some shorts. So I took it back apart, flipped it over. I kept flipping the circuit board over, would unplug it, would make a couple of connections, resoldering it, flip it back over, connect it to power, retry it, see where I was. And one of the times when I flipped it over to do some soldering, I had forgotten to unplug it. I'm not sure how. It was late at night. I was trying to get this done so I could just go to bed. And I heard a fine, high-pitched whine. And from that moment on, 2 of the buttons have never worked since. And it's not the buttons that are damaged. I can make connections with my multimeter through the button. The buttons are fine. But even trying to hook up any other form of input or even an LED as output on one of those digital pins, those last 2 pins. In fact, it's still, even though I'm only using 2 of the last 3, none of those last 3 where I caused that short are working again on the Arduino at all. So of the 8 buttons on this particular remote, I only have 6 of them working, which for now is fine. I only have the 4 camera angles, and the other 2 are then reserved for being able to bring up overhead information when needed. So I already immediately then began work on the second generation, and mostly for the purpose, I wanted to improve upon it two different ways. One is I wanted quieter buttons, and so that's where you see with this generation, they're much smaller buttons, which I'm not happy about. I couldn't find larger buttons, but these are so quiet. I can't hear them at all, even if I bring them right close to my microphone. You can barely hear that. You definitely can't hear it echoing like you can with the other remote. Also, I soldered in the header so that it is much higher up, and all the soldering is now done on this side. In the previous generation, I kept some of the insulation of the wire. I carefully spaced out so the insulation was still here, and it created a nice little safety, if you will, in between all this. I have a ground line running from this all the way around, and I don't know if you can quite see it, on the top outside edges of the switch is going to the ground pin for the microcontroller. Now, when I did all this wiring, I had soldered in the headers, but the microcontroller itself wasn't there. So that left me with enough room to get all of these wires in here soldered. I didn't try doing this with this intact. So this actually went much better. I'm planning on laying down some electrical tape, some insulation to keep this protected while it's in place. The other remote, like I said, it has a lot more insulation on the wire, so it isn't necessary, but I still have electrical tape down there to help protect those contacts. The battery sits up at the top, and I've got that switch so I can turn it on and off through what used to be the emitter for the ultrasound, ultrasonic. Now I can do it this way. I can turn it on and off. So I've got my rechargeable battery. I've got my 8 buttons. This one, all 8 buttons actually work, which makes me very happy. The one thing I'm not 100% happy with this remote is the code. Right now, the code that I'm using, and it's available on I'll have it in the show notes, it's available on our GitHub. It's just a mashing of 2 different libraries. Whenever I push one of the buttons, it holds down 2 meta keys and the numbers 0 through 7. It works. It does the job. As you can see, I can control the show just fine from here. But in the actual computer, sometimes it doesn't, for something in the code, it's not releasing the meta keys. So if I'm trying to do anything else with the computer, I will sometimes hear the bonking of the computer as it's still holding down those meta keys. Luckily, you can't hear it because it's going directly into my hearing aids as my monitor. So there's some stuff I still need to work on. It's not perfect, but stage 1 was just getting a working remote so I can control and get going on season 2. Number 2 is fixing the problems with the noise of the buttons and getting my extra 2 buttons back. The next thing I want to do in the 3rd version is I want to take this original remote. I want to use this in its true form. I want to use that ultrasonic capability. I want to take a remote of the past and bring it back to life. And my plan is to build a receiver, something that will listen to the sound coming out of this remote and convert that to a keyboard. So I'm going to have a receiver sitting next to the computer where I'm using OBS, open source broadcasting system, something like that, OBS Studio, as opposed to what I was using before. This is a much simpler piece of software. I was able to get up and running. I have far less hassle with it. It doesn't have all the capabilities, but everything I needed to do, it can do and more. So what I want to do is have a receiver sitting over there that will hear the ultrasound and map those keys accordingly. So I've got a challenge ahead of me because I don't know anything about how this actually sounds at the moment. Since I've got an 8.4 volt battery, I need to find a battery that I can safely put in this without killing it. Can I use a 9 volt battery slightly above the voltage of this without doing damage to the circuitry? I'm not sure yet. Can I get by with lower voltage, and if so, how much? Doing multiples of 1.5 volt cells in AA's type of thing, I can get 6 volts. I can get 7.5. Can I get to 8.4? Not really, because then I'm at my 9 if I go with another cell. So I've got some challenges trying to figure out voltage, but also I have a couple of ultrasonic rangefinders used for robotics. You can get them all over for microcontrollers. They're ridiculously cheap at times. And I need to hook one up to an Uno and just watch, or better yet, hook it up to my oscilloscope and just listen to the sound coming out of it, or see the sound coming out of it, and then figure out how to map that within a microcontroller to a particular key. So it's funny how what started from I can't stand vintage technology has turned into this passionate love of that same technology and embracing that, and with the idea of going from what was going to be a tiny little remote that I could palm in my hand and you never see to something that has become a staple that some of you have actually asked about. So I'm very glad that you're enjoying the show and where we're going with season 2. Just like with any other episode, if you have, or any other project, if you have any questions about it, you can email us at feedback@Verbose Mode TV. You can also find me on Twitter at Chad Lawson. You can find the show at Verbose Mode TV. And we have a Facebook page. Please come in, share what you're working on, especially if you can give us some pictures. I'd love to see what you're working on, what you think of the projects we're working on, and where you would like to go in throughout this next part of season 2. So until next time, try again, fail better.